Hello everyone and welcome to chapter 11, which I call the 3 final excursions, because we have now arrived at the end of this class. This will be the final videos of this advanced statistical software class, and there will be 3 videos where we will discuss in each video one important concept that we want to mention to make sure that this is part of this advanced statistical software class. We don't want to go into the deepest detail with each of these concepts, but they need to be mentioned that you know that they exist and that they can be helpful for you. So the first video, this video, will be about dependency management with renv. I will talk about this in just a minute. Second video will introduce testing in your code. And the third video will be about something called S3. This is worth listening for you, especially if after this class you want to keep on coding and pursue your improvement of your R skills. So yeah, be prepared for 3 interesting videos and also the next practical. So let's start with chapter 11.1 called renv. And we can put this renv package that we will talk about in a minute aside, and first think about this story or scenario I've drawn up. Imagine this student, we don't know him, but it's year 2023 and he's currently working on his bachelor thesis in an R project, as it should be, writing some nice code, and in the end creating a beautiful GG plot. Cool. All of this works, bachelor thesis submitted, and finally the student graduated and wants to get a job. 1 year has passed, for example, and applies to this person and tells the person, hey, I want this job. All right, well, bachelor thesis look good. Come to my offices tomorrow, but make sure to bring some of your code to showcase, which is actually not that unrealistic, that you should sometimes show some code in a job interview. Well, then I bring my code, or not me, but this student brings his code to the job interview. Our project opened, the code that previously ran now returns an error. Well, now we are both sad. I won't get the job, employer won't get this person. And how did this happen? Well, the problem is that when time passes, of course, packages can be updated or changed, and these dependencies between packages can cause code to fail that has previously worked. But let's narrow this problem down. What do we want in general? We want code that once worked to still work in the future. So if I write something today, I still want it to work in 2 years, even though maybe some functions have updated, some stuff has changed, but stuff where I put a lot of effort in, I can't let it happen that it's not working anymore in 2 years' time. What we currently have to help us with that is the R project as a little helper, and we use that to have kind of this enclosed project that can help us to facilitate the reproducibility, so that we can actually reproduce our result from our code. But what's the big problem? This R project, it's necessary to ensure our reproducibility, but it's not sufficient, because what it's lacking, it does not help to keep track of the versionings of packages, the dependencies between packages, and so on and so on. And what I mean by dependencies, maybe you don't know it, so I just thought I would give an example. Let's say this is all just fictional, but for example, one teeny tiny function called dplyr rename within the tidyverse, in the version 4.0.1 of the tidyverse, only works on R2.2.1. So sometimes things changes, and packages and versions of R and so on are dependent on each other, and just, for example, this version of the tidyverse just works on this version of RStudio. So that is called a dependency, and it's actually a big problem if we don't manage it but just let it happen. Then we run into these issues that your code doesn't work anymore all of a sudden. And as a solution, we do something which is called environment isolation. So all dependencies should be isolated from the computer environment. So it should have nothing to do with the device that we are working on. It should be stored somewhere else, this information of our dependencies. And this would then make sure that our code works on every computer, or put differently, on every environment. And I saw a nice video of the R developers as preparation for this class, and they put it like using something like renv, it stops us from being able to lock our keys in our car, because if you do this dependency errors and issues can't happen to you, or won't happen to you anymore. And yeah, they use this metaphor of locking your keys in your car, because then you're in this well-known deadlock situation which can't really be resolved anymore, and can be really, really horrible also when it comes to reusing of code. And with increasing complexity, this becomes really inevitable. I mean, right now our code that we write in our scripts are not that long. It's all not that difficult, even though we are still very quite advanced in my opinion. But it gets inevitable if you have also with collaboration, with larger scripts, more scripts, software development. In any case, this is really, really important. So we should better start now, once things are quite simple, since things are quite simple, and then we already are used to utilizing renv once it gets more complicated. Well, in our solution, I already mentioned it multiple times, is a package called renv. It's a great tool for dependency management. There are alternatives, but we decided that we would like to show renv to you. It's quite easy to use, the functions. It creates project-specific libraries. So with libraries, I mean, in this case, just a list of packages that you are using for one R project. So you have a library for your project, your bachelor thesis, and one for your seminar thesis. You have specific libraries. And all information about these packages that you are using, the versions, the names, and a lot of information is stored in a file. And it tells us what needs to be uninstalled, what needs to be installed, renv. So we can figure out if all packages are in the right version, if all packages are installed that are needed to have the code run. And also maybe just a detail, but the installed packages are kept in some kind of cache, so we don't need to constantly reinstall. So you don't need to install the tidyverse for each new R project, but you install it once and it's kept separately, and then you can facilitate the installation process. All right, let's have a quick look at the workflow of renv. So to begin, well, this is actually what the name also contains. You run the function renv init to initialize a new project local environment with a private R library. So what that means is you open up a new R project, you run renv init, and that tells it, well, now we have a new project and we want a new project local environment. You see this here with this private R library, so this project specific library I just mentioned. Then you do all the stuff. Let's say, then you do your analysis, your data wrangling, your visuals, and so on. So you, in this meantime, you install some packages. Maybe you uninstall a package. Maybe you update some packages, or even downgrade to an older version, and so on. So you do all the stuff that you usually do. And once your code works, once you're set and done, or at latest point at that time, you can use the function renv snapshot. It saves the current state of your project library, so all the packages that you have currently loaded, all the packages, the version of all the packages, and it creates it uses a file called renv.log. This file will be in your in the folder where also your R project is stored, and this is the important file that stores all the information. Once you made some changes after the snapshot, but you want to return, now the code doesn't work anymore all of a sudden, you want to return to the snapshot because at the time of the snapshot your code worked, you can use renv restore to come back to the state of the project that's currently saved in the log file. So this is kind of a checkpoint in a video game where you can always return to. So that's the summary of the renv workflow. Let's look at all of this in a little bit more detail, but actually running this in R we will do in the next practical session. So you install renv, of course, first as well. So you need to install this packages. Then in an R project, you run the renv init. And what it does, it gives you, when you run it for the first time, some additional information. So that's worth reading. To your folder where you have, in a location where you have the R project stored. So for example, here I have an R project called a practical 11. It created this renv folder and this .r profile file, ignore it for now. But also here we have this log file. So this is where the information about our libraries is stored. Then if our code works, let's say I wrote my bachelor thesis, everything works, or maybe after half of the code, I take a snapshot with the renv snapshot, just as a reminder to save the state of the project library to the log file. All right, so what R then puts out is it shows me what packages would now be updated in the log file, so which would go to the log file and be saved in there, would be all of these packages that I installed. Actually, I loaded them because I installed the tidyverse here. This is quite a long list. Maybe usually you have less packages, I don't know. It asks if we would like to proceed, yes or no, which is a good safety net because we can't take multiple snapshots. And then I type yes because I like this this snapshot, and everything then gets stored in this log file. I opened the log file here in the screenshot with the editor. So this is basically a text file. It contains the information on all the packages. It contains the information for package DBI, for example, here with the version, the source, the repository, the requirements, and so on. So this is all the information. We don't need to understand all of the stuff that's in here, but we need to understand how this log file looks like roughly. Now, let's say after the snapshot, I do some more stuff. I removed the cowplot package, which I separately installed. And then I can use the renv status function to check my current status. And this basically shows the difference between the last snapshot and my current library status. So what I then get as an output, because remember I removed cowplot, the following packages are recorded in the log file. Yes, it was my previous snapshot, but not installed is cowplot because I just uninstalled it. And then it gives me the hint, use renv restore to restore the packages recorded in the log file. So either I could update my snapshot to the version without the cowplot package, or I just type restore because I want to reinstall the cowplot package, or I want to have it back in my library. So when I type restore, the following packages will be updated, and then we see that cowplot will be updated. And again with the safety net, do you want to proceed, yes or no? All right. And when I type yes, so here you just type the Y or the N, in case you didn't know. I think you know that, but yeah, just in case. Cowplot is installed. All right, this worked, and I check my status again. I told you status is the difference between the last snapshot and the current state. And we see the current project. The project is already synchronized with the log file. So log file and current project are up to date, synchronized. Nothing to do here. Maybe it raises to you some similarity with Git. Okay, so basically that was a short introduction to renv, a little showcase how the workflow is conducted. We will look into this in the next practical. Until then, talk to you in video 11.2.